Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 31st, 2025, about 4 days ago. This paper shows that a self-supervised reinforcement learning setup that turns ordinary RGB or RGBD images into verifiable training signals across 5 spatial pretext tasks delivers average accuracy gains of 5% for the 3 billion model and 4% for the 7 billion model over the QN 2.5 volts L baselines, while keeping general vision skills intact. The paper is titled Spatial-SSRL, Enhancing Spatial Understanding via Self-Supervised Reinforcement Learning. And as we'll see later, the implications for model training are quite significant. Also, the authors shared a GitHub repo. You'll find a ready-to-run demo for the Spatial-SSRL 7B model, example cases, and an evaluation toolkit with clear setup and tutorials. The README walks through local inference and links to the release model and dataset. Training code is noted as coming soon. On Hugging Face, you'll find Spatial-SSRL 7B weights at 8 billion parameters with multiple quantizations, plus a transformers example for image and video spatial reasoning prompts. Alright, Figure 1 makes the takeaway concrete. The method fixes spatial mistakes in examples and lifts accuracy across 7 benchmarks. On the left, 2 qualitative cases show the baseline choosing wrong, while the trained model reasons correctly about 3D location and orientation. On the right, a radar chart, which is a spider plot with 1 spoke per dataset, shows the red shape expanding beyond the blue and green baselines. The visual gap signals broader, not narrow, gains. So Figure 2 contrasts 2 training pipelines and shows why the proposed route scales. The top panel depicts extrinsic supervision, where added tools and human labels drive learning, which raises cost and limits breadth. The bottom panel presents intrinsic self-supervision, meaning the training signals come from the images themselves without annotations, so rewards are automatically verifiable. This shift keeps the pipeline lightweight and allows reinforcement learning to run at large scale. Okay, Figure 3 summarizes how the method turns ordinary images into training signals and then optimizes the model with reinforcement learning. The top panel assembles 5 self-supervised tasks that target 2-dimensional layout and 3-dimensional relations, so each prompt has a deterministic correct answer. The bottom panel depicts reinforcement learning with verifiable rewards, which check answer accuracy and add a small format reward. That format queue asks for a think token, then a boxed final answer, and group relative policy optimization drives policy updates. So Table 1 summarizes end-to-end accuracy gains on 7 spatial benchmarks. The 3 billion model improves by about 4.6% on average, which signals broad benefits across image and video tests. The biggest jump lands on Spatial 457 at about 12%, showing stronger 3-dimensional reasoning for complex poses. The 7 billion model adds roughly 3.9% on average, staying consistently ahead. Baselines lost accuracy when asked to produce reasoning chains, while the trained models win with reasoning because the self-supervised rewards teach productive spatial steps. Wrapping up, 2 takeaways stand out. Self-supervised reinforcement learning with verifiable rewards from ordinary RGB or RGBD images reliably boosts spatial reasoning by about 4 to 5%, and it scales without human labels while preserving general vision skills. The broader implication is practical, low-cost spatial intelligence at scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.